Hello, I'm Gleb, and today I'm going to tell you about 5G Dual Active Protocol Stack Handover. Let's get started. Please note, this information just for general purposes. This is not a technical advice, and that's why please use your own guidelines, documents, specifications from your vendor. So, as a part of Release 16 Mobility Enhancement for 5G NR, Dual Active Protocol Stack Handover was introduced. And the major aim of that handover is try to reduce handover interruption time close to zero for possible certain cases. So, how it is supposed to be done? Well, first of all, we should understand that any handovers in 4G and 5G networks are hard handovers. There is no soft handovers like it was in CDMA networks or 3G networks, basically. So what does it mean? It means that connection breaks for very little time and make in a target cell. So dual active protocol stack handover, as you may guess, it allows UE continue simultaneous at least data reception during the handover procedures with source cell and target cell. And this has become possible because of user equipment is capable for that and capable for keep two radio interfaces for source and target cell at the same time for very short time. In order to better understand why that type of handover was introduced in Release 16, let's try to understand what is handover interruption time. Well, basically terminology, we can say handover interruption time or handover execution latency or service interruption time, which is basically not only about handover because a service may be interrupted due to congestions, due to link adaptations techniques, maybe some problems at transport network as well, jitters and so on and so forth. But handover latency, it is pretty huge part. It is usually from 50 to 80 milliseconds in real networks, and it consists of several phases. In a very simple way, this is detached from source cell, some time needed to synchronize in downlink direction with target cell, sometimes need user equipment to synchronize in uplink direction, to send random access preamble, to process all of that messages. And also that time, it depends on what type of network we have. Is it FDD or TDD? Because in case of TDD, it also depends on subframe configurations. It depends on how exactly random access preamble will be allocated in certain slots. So also handover interruption time depends on how well user equipment may retune that baseband and RF part in order to perform handover, especially in case of inter-cell, inter-RAD handovers. Also, some security key exchange involves, and of course radio conditions, at least for uplink direction, because random access preamble may not be received for the first time. It can be, there is maybe a need for one more attempts for sending and reception random access preamble. So as you can see, it is pretty complicated trying to estimate pure handover interruption time. And also I would like to share with you some findings which I found in 3GPP. Actually, it is a part of discussion. Discussion was about Release 16 mobility enhancements, and one of the company, actually MediaTek company, they provided their own estimations as far as I understand in real time, in real network. So, and we can see from that table that main part, even in 5G networks, even in case of 5G user equipment, main part for handover latency, it is UE processing time for baseband retuning. Because I actually remember since I was a student at university, maybe it was 10 years ago, one of the professor, he told me that even at that time with when GSM, CDMA networks were more popular, were more user equipment for that networks. And even at that time, it was pretty challenging for UE to reconfigure, to retune that RF chains to a new target cell. And also, there is some delay for decoding PRACH messages. Before talking about handover diagrams, I would like to highlight possible DAPS handover limitations. Basically, two types of limitation from UE side, which is all about complexity and capabilities of user equipment. There is very high probability that at least first UE with release 16, they will not support simultaneous uplink transmission for source and target cell. Only downlink transmission will be allowed. It will increase complexity of UE in uplink direction. Power in uplink direction will be shared. It will reduce final received SNR. It will increase interference in target cell in uplink directions. So this is pretty challenging to have simultaneous transmission with source and target cells in uplink. Also, in order to perform transmission in downlink, very probably UE will have to perform kind of a downgrade. For example, to release all secondary cells, to reduce MIMO layers, to release any other secondary carrier aggregation cells, and so on and so forth, because DAPS handover is only between primary cells of master cell group and target master cell group. So DAPS handover can only be between that cells. Of course, it will lead to possible data rate reduction, but connection will be kept, and this is very good. Also, there is a description in 3GPP that DAPS handover possible within FR1 bands and between FR1 and FR2, but it is not supported, at least for now, within FR2 bands. I think again it is about you operate with large bandwidth parts. And talking about bandwidth parts, bandwidth part in a source cell should be more than bandwidth part in the target cell. It should be overlapped. Also, limitations from radio access network. Very probably that some hardware, software should be updated. It depends on vendor, of course. Maybe other features such as ratchless handovers or conditional handovers, they not support with dual active protocol stack handovers. So it also should be checked from your side when you try to implement DAPS handover in your network. Now let's look at handover diagram. This is a simplified diagram, of course, for better understanding, and UE configured with measurement reporting. At certain time, it report RSC measurement reports in uplink direction, and if source cell, based on that reports and based on other aspects, decide to perform handover, it may send handover request with special DAPS requirements info to target cell. Target node, based on admission controls, based on some other RRM procedures, may send handover request acknowledged that everything is okay, I'm ready for incoming handover. And then it will be handover command, which is basically handover reconfiguration message. I mean RSC reconfiguration message with DAPS configuration, which can be for different data radio beers. So it means that not for all type of services it can be required. Start from that time, UE try to continue uplink and downlink reception and transmission, but as I said before, very probably only reception will be available because this is less complex. In source and in target cell. Actually, while set up connection to target cell. Also at that time, source base station tried to perform early status transfer, early forwarding to target base station, and target base station try to buffer data and wait for incoming handover from source base station. Then UE performs random access procedure to target cell in order to synchronize in uplink direction and switch uplink from source cell to target cell, but try to continue downlink reception in both cells. If everything is okay, handover, the user equipment send handover complete, which is basically the message RC reconfiguration complete message, plus maybe send PDCP status report in order to target base station try to check possible duplications on PDCP layer and try to evaluate the need. If there is a need for uplink for a user equipment upgrade, because very probably it was downgraded before DAPS handover in order to perform that handover. So if everything is okay, target base station send handover success message to source, and source stops every communication with a UE. Then target base station send RC reconfiguration with the mark that source cell, that configuration from source cell should be released. If everything is okay, UE reply with RC reconfiguration complete to target base station because it is already connected to the only target base station. Target base station send UE context release command to source base station in order to not to keep previous configuration, previous seller and TI, for example, parameters about UE in source node. Now let's briefly touch some new things such as data forwarding in release 16. It is early and late data forwarding. Early data forwarding is used in dual active protocol handover, and it is also possible in conditional handover when data forwarded in advance in transport network. DAPS handover, when it comes to interface S1NG or X2 XN interfaces, it also supported as a legacy handover. There are some references and links for further investigation from your side. So of course this is 3GPP specifications, and my recommendation is MediaTek document. This is part of previous discussion about release 16 enhancement mobility, which is also pretty useful, I think. So it was my short lesson about dual active protocol handover in 5G networks. If you like this video, you can like and subscribe to my channel. Goodbye.